this video, I'm going to be demonstrating how to graph a linear inequality that is in slope-intercept form. Alright, first of all, I would like to review just slope-intercept form of an equation. Alright, y equals mx plus b. Alright, b is your y-intercept and m is your slope. And this is what it looks like when it's an equation. If I put it in the form of an inequality, that just means that this symbol is going to change. It could be less than, it could be greater than, less than or equal to, greater than or equal to, and then that turns it into an inequality. But the variables b and m remain the same. M is still your slope and b is still your y-intercept. Okay, now when you are dealing with the inequalities, you are going to graph this on a coordinate plane. And you're going to, when you put the line that this represents on, you're going to have to make a decision about whether it is a dotted line or a solid line, as in, do the points on that line, are they part of the solution or not part of the solution? Okay, so if you have in your original inequality a less than or greater than, you will use the dotted line because that means that every point on that line will not be a solution to that inequality. Alright, if you have a less than or equal to or a greater than or equal to symbol, then you will use a solid line, and it means that every point on that line will be a solution to that inequality. Alright, you will also need to shade either one side or the other of the line that you graph. Okay, so most often we test the point 0, 0 just because it's easy to plug in. Alright, if you test it and it comes up to be a true statement, like when you plug 0, 0 in, it comes up true, then you are going to shade the same side as wherever that point 0, 0 is at. If you plug 0, 0 in and you get a false statement, as in it did not make the inequality true, you're going to shade the opposite side of where that point 0, 0 is. Alright, so just a nice little summary there if this is your first time ever graphing inequalities. Alright, now let's look at one quick example here. Let's say we're going to take a look at y equals, let's not make that y equals if we're doing inequalities. Let's make this greater than or equal to. Let's go greater than or equal to negative 2/5 x minus 3. Alright, it is in slope-intercept form. So I know that this is my y-intercept. So the first thing I'm going to do is I'm going to focus on getting it graphed. So I need a dot at negative 3 on the y-axis. 1, 2, 3. Okay, then from there, I'm going to run this slope. This slope is a negative 2/5, so I know the slope is going to go in this way. I'm going to do rise over run. I'm going to rise 2 and go to the left 5. 1, 2, 3, 4, 5. And I'm going to put several dots on, so up 2, 1, 2, 3, 4, 5. Out of room there, so let's put some this way. I'm going to go down 2 and to the right 5. 1, 2, 3, 4, 5. Let's do it one more time. Down 2, 1, 2, 3, 4, 5. Okay, now I am going to look at that inequality right there. It's got an equal to part. Alright, so that means I'm going to have a solid line when I actually put it on. Okay, so let's go ahead and graph the line. Okay, now I need to test the 0, 0 point. So here's 0, 0, and the only reason I'm choosing 0, 0 is because it's going to be easy to plug in. So I'm going to test the point 0, 0. Alright, so plugging 0 in for y, 0 in for x. So I'm going to have 0 greater than or equal to question mark. Is that greater than or equal to a negative 2/5 times a 0 minus 3? So is 0 greater than or equal to negative 3? Alright, and we can look at that and we can conclude that that is a true statement. Okay, so that means that the point 0, 0 is a solution to this inequality. Alright, if this point is a solution, that means all of the points on this side of the line is also true. Okay, now generally what I do with especially high school students and everything, we just shade that side of the line. Okay, which I will do in a minute, but a lot of teachers will let you, just do the arrows so that you're not messing up the graph too awful bad. So if you see that type of notation, that just means it's being shaded over here. But generally, I have my students, not solid shading, but enough shading that we can tell that it is shaded on that side of the inequality. Alright, so really just one example there and some rules for graphing inequalities in slope-intercept form. Definitely thanks for watching. If the videos are helping, don't forget to share with your friends so they can benefit too, and subscribe to the channel. Thanks.